Hello students, in this video we are going to learn about electric potential due to a dipole. There are two cases. The first case we are going to discuss at an axial point of the dipole. Look at this diagram here. The diagram shows a system having equal and opposite charges minus q and plus q located at the points A and B and separated by certain distance 2d. And here is the reference point on the axial line of the dipole, which is at the distance r from the center of the dipole. And hence you can also calculate r plus d is the distance for AP and r minus d is the distance for B into P. BP is the distance. Now we have to derive the expression for the potential. Here the potential due to the dipole will be equal to the potential 1 and the potential 2, V1 plus V2. V1 is due to minus Q and V2 is due to plus Q of the dipole. Therefore, we are going to proceed here with the formula V is equal to along the axial line. You can write this also, axial line. And here the potential formula already we have discussed 1 by 4 pi epsilon naught Q by R. Therefore, we are going to substitute that 1 by 4 pi epsilon naught. And the charge is a minus q because due to the negative we are talking about V1. Therefore, upon the distance is what here? A to P, to the reference point P. And plus, what is V2? 1 by 4 pi epsilon naught. And the charge is plus q, we have written here, upon, what is the distance? BP is the distance. Therefore, we can also write in the formula, we can take it in the common way. The common terms 1, that is a q you take here upon 4 pi epsilon naught. You can keep it in the bracket here. That is 1 by BP I am taking here minus 1 by AP. For the sign, minus sign I have taken in this order. So now we can substitute what are the distances of BP and AP. Therefore, V is going to be in this order q by 4 pi epsilon naught. And I am going to substitute this here. BP is going to be R minus D and minus 1 upon AP is equal to R plus D. I have written in this order. So, when we are going to rearrange this, okay, simplify this term Q upon 4 pi epsilon naught. We are going to write in this order R minus D, right, plus D. And we are going to simplify in this order. Minus is already there, r minus d is there, and upon. We are going to write r square minus d square in the denominator. You can do by yourself and you can get the final expression in this order. The final expression will give you here, I am writing 1 by 4 pi epsilon naught. Okay, and I will be rearranging this because q can be taken here. I am going to get as 2d is the answer in the numerator and r square minus d square. You can also solve it and check. And this q into 2d is going to be here what we say, since P is the dipole moment, that is equal to q into 2d, which we have discussed already in the previous chapter. What is electric dipole? Therefore, we can simplify this. I am writing here V axial is equal to 1 by 4 pi epsilon naught and P upon r square minus d square. Look at the diagram here. This is d and the distance is r. Therefore, since d square is much smaller than r square, you can neglect the term here. And hence, the final expression would go like this. 1 upon 4 pi epsilon naught, that is a k value. And we are writing here in this order, r square. And we all know that potential is a scalar quantity. So, we have to write in the scalar notation itself. And this is a formula for the potential due to a dipole at an axial point, which we have written for the short dipole. This is a short dipole of the length 2d. This is a final expression for this. And we also proceed to the second case. What is the second case here? At an equatorial point of a dipole. This is the second case. There is one more at any point on the equatorial. That is the third case, which we will discuss in the next video. And here is a system. Once again we have taken A and B represent the dipole minus Q and plus Q separated by a distance 2D. And here at the equatorial point, that is at the perpendicular bisector, we have kept the point P as a reference point at the distance R from the center of the dipole. And the distance, this distance AP and BP are equal, that is under root R square plus D square. Here also we can write here the potential equatorial, I am writing here, which is going to be V1 plus V2 as the previous one. And here also we can write this is 1 by 4 pi epsilon naught minus Q upon AP, the distance with respect to the reference point. And I can write here, due to the second charge, that is a positive charge, I am writing here Q upon the distance is BP. I am writing BP here. And I can take the common terms as the common terms here, AP and BP, they are equal. And I am writing here 1 by BP minus 1 by AP. I think we need not to substitute and check. Okay, directly we can say this is R square plus D square, and here under root, this is also under root R square plus D square. The subtraction of the term will definitely give you 0. Therefore, we at the equatorial point of a short dipole is going to be 0 when the point P is fixed here for the definite point. Okay, so this is the second case about the dipole calculations, that is a calculation for electric potential due to a short dipole. Hope you understood both the concepts very well. Thank you for watching.